Welcome to this lesson on chemical bonding. Chemical bonding is what holds atoms together to form molecules and compounds. Today, we'll explore the major types of chemical bonds and understand how they form. Before we dive into bonds, let's recall what atoms look like. Atoms have a nucleus containing protons and neutrons, surrounded by electrons that move in specific energy levels, or shells. The outermost shell contains what we call valence electrons, and these are the ones that participate in bonding. Most atoms strive to achieve a full valence shell of 8 electrons, which we call the octet rule. This stable configuration is similar to that of noble gases. There are 3 main types of chemical bonds: ionic bonds, covalent bonds, and metallic bonds. Let's examine each type in detail. Let's start with ionic bonds. Ionic bonds form between a metal and a nonmetal. In ionic bonding, electrons are completely transferred from one atom to another. Let's take sodium chloride or table salt as an example. Sodium, a metal, has 1 valence electron, while chlorine, a nonmetal, has 7. Sodium donates its single valence electron to chlorine, allowing chlorine to complete its octet. As a result, sodium becomes a positively charged ion, Na+, and chlorine becomes a negatively charged ion, Cl-. These oppositely charged ions attract each other, forming the ionic bond. Next, let's look at covalent bonds. Covalent bonds form between nonmetal atoms. Instead of transferring electrons, atoms share electrons to achieve a stable octet. Let's use water, H2O, as an example. Oxygen has 6 valence electrons, and each hydrogen has 1 electron. By sharing electrons, oxygen can complete its octet, and both hydrogen atoms can achieve a stable configuration similar to helium. Covalent bonds can be either polar or nonpolar, depending on whether the electrons are shared equally. In water, oxygen pulls electrons more strongly than hydrogen, making it a polar molecule. Finally, let's examine metallic bonds. Metallic bonds form between metal atoms. In metallic bonding, the valence electrons are delocalized, forming what we call a sea of electrons that flows freely among the positive metal ions. This electron sea is responsible for properties like electrical conductivity. As electrons can move freely, thermal conductivity, heat energy can be transferred by electron movement, malleability, and ductility. The atoms can slide past each other while maintaining the bond. Let's compare these 3 types of bonds side by side. Ionic bonds, electron transfer between a metal and a nonmetal, resulting in strong electrostatic attraction between ions. Covalent bonds, electron sharing between nonmetals, forming discrete molecules. Metallic bonds, electron sea surrounding positive metal ions, resulting in a strong but flexible bond structure. To wrap up, chemical bonds are fundamental to understanding how matter behaves. Ionic bonds form through electron transfer, covalent bonds through electron sharing, and metallic bonds through electron delocalization. These different bonding types explain the vast diversity of materials we encounter in our daily lives, from the salt we eat to the water we drink and the metals in our technology. Thanks for watching this lesson on chemical bonding.